Okay, so I have to imagine, guys, that simplifying radicals is typically one of your lesser favorite items, but we'll see where you stand, because you did do it again, obviously, in algebra. Actually, in some of our teacher meetings, we have found that like the skill of just simplifying radicals, like that first level of skill, just really isn't in the curriculum anywhere. But by Algebra 2, you're expected to do kind of a boatload of it. So it's a little bit of a flaw with the system, but because of that, we're going to spend some time reteaching some of the basics first, and then the more complicated stuff you did last year. You all right, pal?
Yeah.
All right. So the way you present this, it probably changes from teacher to teacher. Like, when I look at the square root of 12 and I'm trying to break that down, actually, let me back up. You can't add radicals unless they're like radicals, right? It's almost like you can't add fractions unless they have a common denominator. Now, you can make any two things have a common denominator. I can't always make two radicals be common. It just either happens for me or it doesn't. But one of these being a radical 12, one being a radical 3, I cannot combine those as is. I need to at least try to simplify something and hope that they become the same. So that would be the radical 12. So I'm looking for any perfect square. Maybe usually the biggest one is obviously going to get you to the best answer more quickly. The biggest perfect square that goes into radical 12. And your perfect squares, in case you forgot them, are listed at the top. 4 goes in. So this is the way I show it. I break up 12 into root 4, root 3. Again, I don't know how you guys do it, and then I don't necessarily always show all this work, but I will now so you can kind of track my thought process. The reason I choose 4 is because I actually know the square root of it, and I can at least get rid of a portion of the square root symbol by making the square root of 4 just the whole number 2. And then the negative 8 that was already there times the 2 that is now there becomes negative 16 root 3 plus the root 3. And just like a variable, if you just see an x, what's the coefficient in front of it? 1. If you just see a root 3, it's technically a 1 root 3. So negative 16 of these plus 1 of these is negative 15 root 3s. I used to, well, I don't even know if this is worth showing. Does anybody do this with like reducing a 12? Like do like that? Is that what you do? That's actually the way I don't know if I was taught that or if that's the way I did it in school, but when I was a student, but I don't know, when I teach it that way, not so much with square roots, but then you get to cubed roots and like, I don't know, I kind of come away from that format. But do whatever you're comfortable with. Now, in the next one, 50. What's the biggest perfect square that goes into 50? 25. So I would make, and then 25 times what would replace 50? Right, so I do root 25 and then root 2x. I'll probably leave that x there. So that becomes, and I'll write one less step here, 4 times 5 is just 20 root 2x. And then how about 32?
16.
Right, root 16 times 2x again. And then that's 6 times 4. So minus 24 root 2x. And then 20 minus 24 is negative 4 root 2x. So it's kind of like combining like terms, just combining like radicals. Something like C, I have an option. I can simplify the numerator, kind of by breaking it down, simplify the denominator by breaking it down, but just looking at that denominator, I can already tell. I could break 6 down into 2 times 3, but 2 and 3 are not on my perfect squares list, so I won't actually be able to follow up with that and take the square root of either one of those. With fractions, you can actually bring it back together all as one fraction. and then reduce the fraction first. So what's 96 divided by 6? 16. And x to the 5th divided by x is x to the 4th. And then I'm good here. So this in and of itself, 16 doesn't need to be broken down. I already know the square root of it, so I'm just going to leave that as 16. Square root of 16, when I take it, is just 4. And the square root of x to the 4th. What did you say, Faith? X squared. Good. If I know you don't do it with a square root, but if you have a little 2 there, it's really, how many times does 2 go into 4? Twice. So that's x squared. Any questions? Oh, it is. Now, if I get to cubed roots, I've got a different task here. I don't care that 4 goes into 24. 4 is a perfect square. I'm not looking for perfect squares when they're asking for the cubed root. I'm looking for perfect cubes. So we look at a different list. And there's a lesser number of perfect cubes that you have to be familiar with simply because they get so big so much faster. So of those numbers that you see there, which one goes into 24? 8. So 24 is going to be broken down into 8 times what? 8 times 3. And then, just like in the last one, the one that I know the value of is the cubed root of 8, which is just 2. And then cubed root 3 is just kind of hanging out. So that simplifies there. On the next one, same thing. I can't add and subtract these unless they're like radicals. So if I look at the cubed root of 16, is there a perfect cube that goes into 16? 8. So I'm going to go cubed root of 8 times cubed root of 2. The cubed root of 8 is going to be the whole number 2 times the 5 that's already there. It's going to give me 10 cubed root 2. Minus, and this one nicely I don't really have to do anything with. Minus 11 cubed root 2 is negative 1 cubed root 2. Or that 1 doesn't really need to be there. It could just be negative cubed root of 2. Now, if you're ever feeling like on a test, like you've got extra time and you're not confident with those, you can absolutely test them on your calculator. Like 5, do you guys know how to type in the cubed root of 16? You hit the 3 first, and then if you go to your math, oh, you don't even need that here. For cubed roots, you don't need to do that. Cubed root 16 minus 11 cubed root of 2. And it's going to be a crazy decimal, but if you think it's simplified to the negative cubed root of 2, you can just type that in. And it should be a match. Just to, if you ever want to check yourself. What's that? To be truthful, I don't really like navigating for the cubed root under the math function. I would just raise it to the 1/3 power. To me, that's just faster, but whatever you want to do. It's harder to do with variables, obviously, because you don't have a number to plug in. But you could always decide in your own head that x is going to stand for 7 and test it with that. But at any rate, when you're multiplying radicals, and this hasn't come up yet, just like with fractions. With fractions, adding and subtracting is actually harder because you need a common denominator. Multiplication is easy because you just flat out multiply, commonalities, numerators by numerators, and denominators by denominators. Radicals are the same thing. Adding and subtracting is a pain. Multiplying, really not a pain. I just am going to, the 4th root's going to stay the 4th root, but that's going to become 32 x to the 5th. And so we don't have perfect 4th powers as a list, but we can easily come up with them just by, obviously, 1 to the 4th power would give you 1. So 1 has a 4th root of 1. 2 to the 4th power is what? 2 times 2 times 2 times 2. 16. So 16 is a perfect 4th power because the 4th root of it is 2. And 3 is probably the last one you might want to know. What's 3 times 3 times 3 times another 3? 81. And then as far as variables are concerned, do you see the pattern? Obviously, perfect squares, x squared, x to the 4th, perfect cubes, x cubed, x to the 6th. The exponent needs to be a multiple of 4 in order to be a perfect 4th power. So x to the 4th, x to the 8th, x to the 12th, so on and so forth. So, and this is the first time we're coming across this with the variable. We can find what is the biggest 4th power that goes into 32. 16. So I'm going to break that up into 16 times 2. Now, x to the 5th, the way we're going to handle that is different. We're going to look for the exponent that 4 goes into evenly, that's closest but under 5. 4. So I'm going to break up x to the 5th into x to the 4th times x, right? X to the 4th times x is a good replacement for x to the 5th. But I did that because now I know the value of that is just x, and I know the value of that is just 2. So anything that I can actually take the radical of comes out in front as like a whole number, 2x. And then anything that I don't know the radical of still should be smaller, just stays kind of locked underneath the radical. So 2x and the 4th root of 2x. Any questions? There's one type of thing I didn't see that I want to add. Like if I have 3 times the cubed root of 2x times 5 times the cubed root of, I don't know, 6x. Like if you're doing multiplication, like I said, you don't need like radicals. But if there are coefficients out in front, that's just going to be 15. And then cubed root of 2x times 6x is 12x squared. So the one we just multiplied below didn't have coefficients. So I wanted to address if there are coefficients, the coefficients get multiplied by each other, and what's under the radical gets multiplied by each other. And if they're both cubed roots, it stays cubed roots. What if they're not both cubed roots? What if it's like the cubed root of 2x times the 4th root of 3x? What'd you say? You could do that just to kind of brainstorm, but you actually can't do that. You can't multiply. Well, if I did 2x to the 1/3, is this what you're saying?
Yeah.
3x to the 1/4. You're still always going to have. Right, you're still going to have 2 to the 1/3, x to the 1/3, 3 to the 1/4, x to the 1/4. You can add those if you get a common denominator. These are just going to be cubed root of 2, 4th root of 3, kind of separate. You can't really bring those together. Although I just had a thought. Like if this isn't going to come up, I don't think. Otherwise, I would think there'd be an example of it. But you could probably make that 4/12 and 3/12. And then just do it all, kind of get them to have that like index, and then just do the 12th root of everything. If you really wanted to condense it, you could do that. It's not going to come up, so I'm not going to waste time. I was just brainstorming. All right, rationalize. What does rationalize mean? Right. No radicals allowed in the denominator, says someone in math 3,000 years ago. So we still follow that rule up until you get to calculus. Then we don't really pay attention to that rule anymore in calculus. But it is a skill. You definitely have to know it. So there's really 2 different cases. This is one case, and these 2 would kind of fall under a different case. What are the differences between A versus B and C? You handle each of them differently. Anybody remember from last year how you handle something like A versus B and C?
For A, you can use multiply times equivalent to 2.
And for B and C?
I would try to figure that out like testing. It's like
You don't remember that? Conjugate.
Oh, so it'd be like
I think that's what you
minus
meant.
radical 3.
Right, so this denominator is a monomial. When it's a monomial, you can just multiply by the radical portion over itself. So you're multiplying by 1, but in kind of a fancy way. You're multiplying by 1, so you're not changing the value, but you're doing it in a fancy way, so you change the appearance. So your numerator is 4 root 2, and your denominator is just 2. And then usually, not usually, but maybe 50-50, half the time, once you finish that step, there's then a follow-up simplifying to do. 4 root 2 divided by 2 is what? 2 root 2. We definitely don't take the what's under a radical. If we're dividing by a whole number, that what's under the radical does not get divided by that whole number. But sometimes people will see that 2 divided by 2 and want to do that, but you can't. So in B and C, because we're dealing with binomials as the denominator containing a radical, this is where the conjugate comes in. So again, we're going to multiply by 1. Anytime you multiply by something over itself, you are multiplying by 1, but it's a fancy way that's going to change the appearance. A little bit more work, I guess, just in the sense that you have to distribute, because you are multiplying by a binomial. So if you want to put that binomial in parentheses to help you remember to do that, same thing with a denominator that was already a binomial. It didn't have parentheses around it because it was already grouped in the denominator, but for visual purposes, I think that helps a lot of you. Distribute your 7, you get 35 minus 7 root 3. That one's a straightforward distribution. In the denominator, you have to FOIL. Remember the beauty of conjugates. When you're multiplying by conjugates and you're FOILing, the outer and the inner are always going to wash, because one's going to be a positive version, the other is going to be a negative version, and you don't have to worry about that. So you just have 5 times 5, which is 25. And then positive times a negative is a negative, so it'll always be a minus there. Root 3 times root 3 is just 3. We didn't have to worry about the minus 5 root 3 on the outside and the plus 5 root 3 on the inside. Those cancel. So after that's done, what's my final numerator, Ryan?
35 minus 7, not to the root 3.
Yeah. Over.
And then over 25 minus 7.
I already wrote that.
I actually think that it would just be...
I have to go one more step with this. Just simplify that one step more.
I'm
Okay. So 35 minus 7 root 3 over 22. Does anybody disagree with that? Look at Ryan's like defeated. He's defeated. Watch this. Connor?
Isn't it 5 minus radical 3 over 22?
5. Say that again?
Can you cancel out the 35 minus 7 just to be 5 minus radical 3?
Did you do 35 divided by 7 to get 5?
Yeah.
Why are you dividing 35 by 7?
Oh, I can't because it's... Never mind. No, that's right.
You take out 5 and 35
It's 22.
Oh, here?
Yeah, there.
No, you can't. If you had me, I talk a lot about in Algebra 2, like you can't cross out pieces of polynomials. So, for example, if you have like 10x minus 1 over 5, you can't just divide one term by 5 because it conveniently works. You either divide everything by 5, so this would become 2x minus 1/5, or you just leave it like that. But you can't just make that a 2x minus 1, because that's like a piece of a polynomial.
Yeah.
So, Ryan, you were good. Yeah. What I was looking for and nervous about were people that might have made that 28 root 3, because they're doing 35 minus 7, which is a big no-no, which is kind of what you were trying to do, but then you divided.
Yeah.
So I was a little thrown there. But, Ryan, you have confidence. You were good.
Oh, I don't have confidence.
You were...
Sweating my butt off.
Because you're nervous or because of the heat?
Math just really frustrates me.
So that makes you sweat.
It's more angry than anything.
So you're sweating because of the nerves, not the heat in the room.
Well, there's that too.
Yeah.
It's a lot of stuff.
It's supposed to be 75 today. You got a hoodie on, my friend. Okay. Style first. Beauty hurts, right? All right. And C is going to be similar, just obviously a little more complicated up top because we're going to have a binomial there as well. So the conjugate that we multiply by, Alyssa, is what? Very good on both the numerator and the denominator. I'm going to throw every single one of those in parentheses just to be careful on my foiling. So top first, root 3 times root 3 is 3. Now, even though those two that we're about to multiply in the numerator are similar looking, they are not conjugates, so I can't bypass that outer and inner step. My outer is minus 2 root 3. My inner is also minus 2 root 3. And then I have plus 4. So that numerator, I'll just kind of see this through to the end. The 3 plus 4 is a 7. And negative 2 root 3 minus 2 root 3 is negative 4 root 3. Whereas on my denominator, I designed these to be conjugates. So root 3 times root 3 is 3. My outer, negative 2 root 3, will cancel with my inner, which is positive 2 root 3, so I'm not even going to write that. And then minus 4, right? 2 times 2. So just negative 1. Now, I would be shocked if you saw that as the final answer, because anything is divisible by negative 1, right? So you would definitely want to clean this up just a little bit more to be more presentable and actually divide both terms by negative 1, which is really just going to flip your signs. You're going to get negative 7 plus 4 root 3. Any questions? Yeah.
You still leave it in the fraction formula if you wanted to?
No. You would lose points for that because in general, the final answer should be in simplest form, and that would not be simplest form. Right, so and same is true. If you ever get 16 minus 8 root 3 all divided by 4, you can't leave it like that, right? When, and Christian, this is like back, now if both terms are divisible by 4, which they are, the 16 gets divided by the 4 to give you 4. The 8 gets divided by the 4 to give you 2 root 3. You have to do that to get it in simplest form. Yeah. Then you can't do it. So that brings us back to like this point. If only one of them is divisible, you can do it and leave it like that, or you can just leave it like this, because you can't really argue which one is simplest form in this case. They both would kind of qualify. So you kind of have a choice there. All right? Good questions? Anything else?